talk about R squared. R squared is a really important concept when we're talking about linear regressions and multiple linear regressions. R squared is the statistical measure that represents the proportion of the variance for a dependent variable that is explained by the independent variable in our regression model. What does that mean? Let's say we want to measure or predict extremism and what drives extremism. That'll be our dependent variable. We will throw in a bunch of independent variables like age, gender, marital status, income, and a whole bunch of other variables. And what we're hoping to do is that these variables will help us determine the extremist value somebody has. Now, the R, or the coefficient, will tell us how strong that relationship is. What it doesn't tell us is how good our model is at explaining that relationship. So sure, we might have a positive relationship between age and extremism, i.e. as you become older, you become less extreme. But how well does that model explain it? So R squared is the value that explains how good it does so. Now, R squared, you see the formula on the left hand side, is made up basically of the standard squared error, or the sum of squared errors, or the sum of squared residuals, which we've covered early on, and the total sum of squared, the total variation. So the other thing to remember is when we have R squared is that in a multiple regression we use something called adjusted R squared. So in a simple linear regression, when we add more variables, the R squared will automatically go up. And that's not a good thing. And so what we do is we adjust for additional variables, and it gives us a much more accurate result. So when you have a linear regression that has more than one independent variables, you should always use the R squared. Now, the R squared is interpreted on a scale of 0 to 1. 0 being no relationship, it doesn't explain, the model doesn't explain anything, and 1, the model fully explains the phenomenon, and obviously everything in between. In the social sciences, we generally are looking for something 30-40%, so 0.4 and upwards. It's very rare in the social sciences that you get anything that explains 100% or even 80 or 90%, and that's worth keeping in mind. Just a reminder, the difference between R, which is the correlation coefficient, and R squared, is that the correlation coefficient determines the strength of the relationship. So is there a strong correlation? So does extremism go up with age or not? Could be positive, could be negative. The straighter the line is, the more weak the correlation is. The R is different. Again, it looks at whatever line there is, and it looks at how close everything fits that line. And the closer the data is to the line of best fit, the stronger our R squared or adjusted R squared will be. So just remember, when you are running a linear regression, you should always look at your R squared or adjusted R squared, because it will tell you how good your model is and how well all the different independent variables explain the dependent variable.